in basically you have two requirements, coverage and capacity. You can definitely have good coverage um, uh, everywhere. You can cover from the satellites because it's located up above, and you can better avoid coverage holes that you sometimes have with the terrestrial deployment. However, it's a problem in the capacity. In the capacity, the demand for capacity is growing so fast, and uh, it is an ever-growing factor. Okay, it keeps growing indefinitely. You have the growth for the demand of data rates. The data rate per unit area, per unit geographical area, right? Because of the, I mean, the number of people, the growth of the data of individuals. So you gotta have the provision for indefinite growth of the capacity. Okay, with satellite, you could go up to a good level of capacity, but not beyond that. You get limited somewhere. Okay, and what would you do thereafter? The project would become much more costly by then when you reach that level, and thereafter you have, I mean, you would start losing your customers. Okay, so I was trying to explain why you get limited. Well, uh, let's assume you have a cluster size of 3. You have just 3 cells in a cluster. That's very practical with the advanced, with the new generations like 4G, 5G. You may have only 3 cells in a cluster. Also, it may also be possible that you have just 1 cell in a cluster. Okay, so you repeat the same frequency spectrum in every cell. If you have 1 cell in 1 cluster, or if you have, I mean, frequency reduce factor, okay, is 1 over n, or it is also called, it can also be shown as n. But if it is, let's assume it is 1 over 3. Okay, you have 3 cells in the cluster, so you have like 15 megahertz in total, and you split them into 3 cells, so 5 megahertz. Okay, now if you can reduce the cell size, then you will have, actually we explained these things before. If you can reduce the cell size, then this same 15 megahertz would be repeated uh, in a, I mean, in higher number of times when you cover a particular geographical area. Okay, as you reduce the cell size, or if you think the way that you have just 1 cell in the cluster, you're repeating the same spectrum in every cell. As you reduce the cell size, there will be the same spectrum you use in a smaller area, and then again you reuse, and again you reuse. So that way you allow more spectrum per unit geographical area, and that's how you allow the capacity to grow. On
So
one
it
side,
is due to this repeating capability
yeah,
of the
just
ground
right,
level space
right,
station.
right.
Okay.
Almost indefinitely, you can let
Yes.
it grow. As you keep reducing, as you keep reducing the cell size, almost indefinitely. It is almost indefinitely because you are still limited by whatever bandwidth you are given. Okay. Uh, that bandwidth you are repeating. Okay. So uh, if you had wider bandwidth, then it would be more helpful for you. But that bandwidth you can keep reducing. I mean, uh, the uh, eventual condition you can think of is that a single user is using the whole bandwidth. People will not go to that level, but uh, that can be the imagination. Okay, so you just keep reducing. So the point is indefinitely, almost indefinitely, you can grow the capacity um, uh, with terrestrial deployment. You have this provision. uh, and the demand is growing very fast. Um, and probably I mentioned, I don't remember exactly, that the small cells are getting very popular in 4G and especially in 5G. Okay, they are called UDN, ultra density network. Okay, the cells are so small that the network seems to have very high density. Okay, so it's then called UDN, ultra density network. Okay. Um, um, so the trend is already there. Okay, to keep reducing the cell size. I mean, reducing it to a very small size. Well, in the case of satellite, you have the limitation. You are covering from a point far away. So every cell you have to cover using a different transponder, using a different antenna. And from that distance, how much you can reduce the cell size. For a different cell, you have to use a different antenna, and uh, I mean there will be a limitation in the reduction of the cell size. Okay, so spotting uh, a number of cells, okay, is possible, but you can't indefinitely keep reducing the size of the cells from that distance. Okay, so you have to do it right from the spot. Okay, not from a distance, right from the spot, right from the ground. Okay, you have to do that. Okay, so it can be, I mean, if you just as I said, the imagination that you a base station is covering just you, you're the only user of your base station. Okay, the base station should be right next to you. There is an another person and there is another base station right next to him. Okay, so you can, so that is definitely not possible from the from far distance. Okay, so anyway, so they realized the reality and they dropped the project. However, it was actually handed over. Motorola dropped, but someone else took over, and we definitely have satellite-based cellular services. Okay, there are four major operators, and we started this discussion. So we'll show what we operation we have in this area. Uh,
Sir,
yeah.
sir, sorry to
Yes.
interrupt you, sir. Like, we got
Sure.
question relating to this, sir.
Hmm.
Like after the mid, sir, whatever we have learned, all the slides are very elaborate, sir. But sir, in the mid, sir, the questions that you gave, sir, the type of
Hmm.
questions, those were a
Hmm.
lot more conceptual. So, so sir, how should we proceed with all the slides that came after mid? Like, should we take concepts from there, or it's like, do we have to learn it, the slides? Because
Uh,
those are pretty large, sir. It's like
yeah.
yesterday we had the confusion of that 15 and 16 and 17 and 18 for that same reason, sir. Because 17 and 18,
Mm.
like, or a little bit smaller than 15 and 16. So yeah, but
Yeah.
in the final, all of them will be included. So
Well,
oh
I just feel pity on you. Yeah. I mean, you got
yes, sir.
to learn, you got to learn both the
Yes, sir.
elaborate information
Yes,
as well as the concept. Okay.
sir.
And I'm really sorry about that. Uh, I mean, uh, yeah, you're in a distressful condition. Okay.
Yes, sir.
We should. Uh, I mean, my condolence for you.
Yes, sir.
Okay.
No problem.
Now the um, s- satellite-based cellular services called satellite phones. Okay, I mean at the user end, it's called satellite phone, or in short, sat phone, and they are directly connected to the satellites. And these satellites can be GEO or LEO. And um, it, in most part of the geographic locations you can use, as we'll see that there is just one operator which covers the whole world. And the primary service includes voice calls and SMS. Okay, uh, the bandwidth support is very small, so it's basically um, a phone for emergency use. Okay, or for use in some critical areas. Okay, we'll talk more about that. And some light data services are also available nowadays. Initially, they were not, but later some, like you can send emails or okay, this kind of light data services you can do. So primary use cases include adventurers, explorers, hikers, and travelers in expeditions into remote areas. Okay, so like if you wanna uh, climb the uh, Himalayas. Okay, okay. Um, I'm sure some of you will do uh, the kind of spirit you guys have. Okay, and in remote industrial plants or in deep seas. Okay, in airways. I mean, it's available everywhere. In airways, also you can use it. And the third point is that if you have a disaster and which damages your terrestrial system, then what would you do? Okay, there are actually many different options proposed for the to address this kind of situation. Set phone is one of these options. I would say from the operation, from the uh, viewpoint of advantage, is the best option. Okay. In other options, you quickly set up some system, but satellite based phone services will definitely be available already. You don't have to set up anything in the situation of a disaster. Okay. it will def- it will be available anyway. Okay. So there can be workers in the mines or something. I mean, so in that part, not far inside the mine, but I mean there are some areas which are not covered by terrestrial deployment. So all in these areas you can use satellite-based phones. However, unlike cell phones, the satellite phones require line of sight with the sky to receive the signal. Okay, so if you have uh, uh I mean good shadowing, okay, then it may not work. So heavy tree, okay, or any kind of obstacles, okay, which can uh, just offer good shadowing Okay, you may lose the signal, so sometimes it may not work indoors. Well, near the large window it may work. Okay, so it depends. So we know that the path loss is large for satellite. Well, now if you are using geo satellites, then geo satellites, I don't remember if I told you, the geo satellites all lie above the equator. Okay, all the geo satellites lie above the equator. There was a position of geo satellites at every 2 degrees. I don't know exactly how it is now, but probably it is the same. At every 2 degrees, there is one geo satellite above the equator. Um, anyway, so when you cover from the geo satellites, okay, you cannot cover the polar regions. It goes towards only towards the latitudes. It goes only up to 70 degrees. Okay, not up to 90. At 90, you have the pole. So 70 degrees is quite large. 70 is quite large, right? So it covers actually the uh, basically, I mean, almost the whole area where you have civilization. So the service is available only, I mean, almost the. However, for the case of, so I mean, you can argue that the area, I mean, the part of the world where people live in is basically covered with geosatellites. That's true, but for satellite phones, the concept is that there can be some extreme conditions, and in those conditions also some service should be available. Okay, so that is not fulfilled here. You're not covering the whole world. However, so geosatellites are good if your requirements are fulfilled within this area. And the line of sight link can often be obstructed by some hills, forest. Okay, as you cover from geo. And also, when you go pretty far from the equator, then the angle becomes low. Then it can happen. There are high chances that you get. I'm sorry, I got disconnected. I was saying that when you go pretty far from the equator, the angle becomes very low, and especially in this kind of condition, there are more chances that you will get obstructed by something around yourself. Okay. Well, so I mean, it is better when you are closer to the equator. Okay. The geo satellite phone operators. You can hear me, right?
Yes, sir.
Okay. The geo satellite phone operators, Inmarsat and Thuraya. Inmarsat is the oldest satellite phone operator, and it's a British operator. They initially had, I mean, target market for the ships only for in the Navy area. But now their service is available commercially. Okay, and they have 11 satellites. So as I said that the coverage is available in the most of the Earth except the polar regions. Thuraya has smaller coverage. Okay, unlike Inmarsat covers like pure, complete geo operators. Okay, but Thuraya has limited coverage, and uh, they cover Europe, Africa, Middle East, Asia, Australia. Okay. Um, so these are the two geo satellite phone operators. Now we'll talk about LEO satellites, satellite-based sat phone services, and there are also two operators over there. So in total, there are four. Okay, two G operators and two LEO operators. Okay, so there are four sat phone operators in practice. There are few other operators like these things which are uh, this the upper two MSAT and ICO, they are they have some services, limited services, but not really available for public use in a commercial way. Okay, like in some industries. Okay, uh, so they can be used. Okay, some limited use cases they have. Okay, also they are growing. Now with satellite LEO satellite phones, you have the satellites. A number of satellites you then need. Okay, and similar to the GPS deployment, you have many satellites around the world, and if you you may be using service from one satellite before it uh, passes yourself, it goes beyond the horizon. Another satellite should arrive and take over. Okay, so that's how you need quite a few satellites. And uh, in the case of LEO satellites, you have an advantage that the latency is lower compared to the GEO satellites. Well, one of you raised the point latency. Yes, latency is definitely a factor these days. Okay, but when people were first starting this uh, satellite-based projects, then latency was not that crucial. Okay, now definitely people are uh, targeting latency uh, to a very low level, less than 10 millisecond or even less than 5 millisecond. Mhm. Okay. So these are the two LEO satellites, Global Star and Iridium. Uh, Global Star covers most of the Earth, but many areas are left. Okay, polar regions are not covered actually. Also, although with LEO satellites it's possible, but they don't have that much that wide deployment. Now, Iridium is the best solution in all respect, and is the only operator that covers the whole Earth. It's actually the same project uh, started by Motorola. Okay, so now it is operated by a different company, um, but they have 141 satellites, and initially Motorola had the target of 66 satellites to cover the world. Okay. Uh, Anyway, and they actually built quite a few satellites. Okay, in their project. Bef- they had built them before they dropped the project. Now, Iridium is the largest commercial satellite constellation. Okay, and the service available everywhere. So if you are a traveler, like I mean, you wanna go, anywhere, okay, then take this service. Again, it's a satellite, it's a service, outcome, okay, with some limited, uh, with some limited operation, okay, and communication for industries. Well, if you want to use it in our country, um, probably you cannot. Okay, some special um, authorities can only use satellite-based phones, and if you want to use otherwise, then you have to take permission, and that will be very complicated. Okay, so there are strict restrictions on the use of satellite-based phones. It's because you the government wants to have good tracking of the communication. Okay, evildoers uh, may uh, get successful when they can communicate furtively. Okay, and they can go for a mission. Okay, because in every mission they need communication among themselves. Uh, so the government wants to uh, track, and with the terrestrial operations of the cellular services, they can do that. All the cellular operators have the bindings, and they know where their users are. But from the satellites, you can have services anywhere, and using that service, you can definitely uh, be out of control. Okay. So this is why we have they have the restriction. Questions. There is the last slide on this satellite. Questions. Okay. Our next discussion is on uh, something called link budget. I actually mentioned that we would discuss this link budget for two example wireless cases, one in non-LOS and the other LOS. And the example cases we are taking mobile services and satellite. Okay. So, and before covering that example link budget calculation for these two cases, we wanted to cover the fundamentals in these areas. Okay. So now we will move to link budget discussion. It's a calculation for the determination of transmit power, or uh, basically actually different things you can calculate, but basically how much power you may use at the transmission end, or if you know the transmit power, then how far you can cover, what may be the distance, uh, maximum distance between the transmitter and the receiver. Link budget for wireless link. The key purpose is to determine the transmit power or EIRP at the transmitting end, okay, or to determine the coverage distance, the distance between the transmitter and the receiver. Also, to ensure path balance between uplink and downlink. Okay, so you have proper. Uh, okay, we'll explain it using the, which is. Uh, I mean, this factor is more prominent in the case of cellular application, and we'll explain using the cellular case. Okay, so on one side, between uplink and downlink, on one side you may fulfill the requirement, but at the other side you may get limited. Okay, yeah, I mean, you don't have enough transmit power available. The coverage distance that you have already used in the downlink is too much for uplink. You cannot actually uh, use the required transmit power there, so then it will be a problem. So you can check beforehand whether or not you are getting to this kind of situation. So a few things we wanna discuss, like in this background discussion, like so the common KPIs for communication links. Okay, what are the key performance indicators? When you comment on the performance of a communication link, yeah, how well it is performing, then what factors, what indicators you look at? There are many different indicators, but I'm just listing the most important ones. The first one is how much data rate you can support. Okay, all of you probably use the only this one. Okay, how you look at when you receive the service, you check how much data rate it is currently offering. Okay, so it is also called throughput. uh, but the engineers who are checking what is going on uh, in reality, so they would look at other things, like how many packets you have in error. Either uh, it may uh, they may look at BER or blur, okay, at the packet levels, or how many bits are in error, okay, bit error rate. For BER, the whole term is either bit error rate or bit error ratio. They both mean the same. When you look at the number of packets in error, then you can use either the term block error rate or packet error loss rate. Okay, they both mean the same. Then the third important indicator is latency, delay in transfer, data transfer. Well, I'll tell you something here about latency. Um, it depends on two different things. Okay. Like you consider sending water from a water reservoir, okay, using a narrow water pipe. Okay, so you when you the water pipe was empty, and you may assume that you have a valve, okay, at between the water reservoir and the water pipe. So as soon as you open the valve, water comes to the water pipe, and then it starts flowing, and you have a destination. So you wanna check um, how much time it takes to get to the other end. Well, um, so um, when you measure this way, that a particular amount of water, okay, you are considering to be transferred to the other end. How long it is taking for this much water to go to the other end. You may have another reservoir at the other end. So how long it is taking? In this case, two things will affect you. First, um, say when the first drop comes to the water pipe, that drop will take some time to reach the other end, and that is your propagation delay. That is equivalent to what we call propagation delay in the wireless signal. Okay, the drop has already come to the water pipe, okay, at the beginning point of the water pipe. It will flow through the water pipe and it will get to the other end, the destination reservoir. But it will take a while to go there, right? So this is like a propagation delay. Okay. But when you get the first drop, it doesn't help. You need certain amount of water on the other side. And the transfer of this certain amount of water now also depends on the width of the water pipe, how fat it is. So two things are affecting the propagation delay, which is like, say, the distance. If you have a longer distance between these two reservoirs, then the first drop will take longer. Actually, every drop will have to go through this distance, will have to experience this propagation delay. In addition to that, the width of the water pipe would affect. So that with that you can tell that how much you have this much data, okay, and this is your bit error rate, okay, like the width of the water pipe you can compare with the not bit sorry with the throughput. Okay, the width of the water pipe is equivalent to the throughput, the data rate. So with data rate, you need to calculate how much time it takes to send certain amount of data. So you may have 1 gigabyte of data. So you have certain data rate. So how long it takes to actually let this whole 1 gigabyte flow. Okay. So it is like the width of the data rate is like the width of the, but each of the bit will also have, I mean, in addition to that, you need to just add the propagation delay to that, because every bit has to also experience the propagation delay. Did you get the point? Did you get the point? So that's how the whole latency is calculated. Okay. We're not covering it in detail because you have a different course, but that is optional. So I'm not sure if all of you have taken that course. There's data and networking. I mean, that also has 1 and 2 in this semester is part 1. Okay. Most of you have taken that course, right? It's also a good course. Guys, I mean, was this latency calculation covered there? Hey, do you hear me? Do you hear me?
Yes, sir.
You do? Okay. So Arnav responded. Have you taken the course data? The course number is probably 4551. Have you taken that course?
Yes, sir.
Okay. Uh, Well, let me ask you, if anything that we are discussing here is also covered over there, we can actually drop that. I- Is, is any part of our discussion here in this wireless communication course is also covered in that course? Enough?
Sir, Internet of Things is being covered right now.
Okay. I see. Okay. Sounds good. Okay. Now, the latency cal calculation, okay, may also be covered there in that course. Okay, that's why I actually wanted to ask you. Uh, I'm getting disconnected. Okay. Now, let us look at these two different types of applications: real-time applications and non-real-time, RT and NRT. At the bottom table, we have the examples. Like in the case of voice, you have real-time data transfer. At the two ends, uh, there is a continuous communication. Okay. Live streaming video. You are watching something, so there has to be a continuous uh, data transfer. So you wanna know what is happening live. Similarly, in real-time gaming. So in all these applications, the latency is a crucial factor. Like for real-time gaming, if the server is located nearby, okay, you're connected to a server, and the server can be located, anywhere. But if the server is located nearby, then you have less latency and you enjoy better. Okay. So similarly, for all these real-time applications, when you're talking to somebody, if there's significant delay in the data transfer, okay, significant delay means latency, then you won't feel good, right? Um, so for real-time applications, delay is a crucial factor, or the applications are sensitive to delay. However, when you are checking your email, okay, it may take a while for the whole data of the email content to be downloaded, and you may be okay with that. When you're downloading a file, okay, uh, there may be, say, uh, a few seconds delay for some packets to arrive, okay, or even if it is a few minutes delayed, it doesn't bother you too much, right? By actually latency here, we mean a small level of it, in the order of seconds or in the order of milliseconds. Okay, the delay actually it is counted in the order of milliseconds. But even if you have some delay in the order of seconds, okay, you don't mind for the NRT type of applications. Um, well, and in some cases, even if it is in the order of minutes, it may be okay. So for all these NRT type of applications, the user is tolerant to the delay to some good extent. Okay, so you have these two type of applications. I mean, real time and non-real time. Where you're communicating uh, live. Okay, then we call it real time. Now there is another way to consider their acceptance level, and that is the error. Now, you please check how you are tolerant or sensitive in terms of error for these applications. You see, for the RT type of applications, say voice or say live streaming video, if there are some packets in error, it won't harm you too much. Okay, I mean, say our audibility has some limit. If some voice packets are dropped, you may not even recognize. When you are watching something, the picture quality will be very little hampered when some packets are dropped. Okay, so you can accept. So RT type of applications are tolerant to errors. Okay, more bits can be an error, so it's okay. You said. However, when you are downloading a file, maybe say a PDF file you are downloading. In this case, if you have some packets in error, then you cannot open the PDF file. For your email, if you have some packets in error, then your email will be erroneous. Actually, it's not. I mean, your email client software will not work. Okay, the errors it cannot allow because your I mean, email content will then be erroneous. That is not allowable. For the NRT type of applications, you don't allow the errors typically. So in terms of errors, RT type of applications are tolerant, NRT types are not, right? Is it clear? So the upper table summarizes this fact. For error case, which application is sensitive and which is tolerant, for delay, which is sensitive and which is tolerant. Okay, there could be a question now whether there are applications where I mean, which is sensitive in terms of both error and delays. Yeah, there are, but those critical cases we're not considering now, and this type of applications are basically addressed these days. Until recently, people did not have that kind of critical applications where you have sensitivity in terms of both error and delay. This is a summary of those applications for LTE. How much delay you may typically allow and how much error loss is from the specification. Okay, I mean, how many packets you may have in error, packet error loss, right? Okay. So you see that in the case of voice, 1% packet may be an error. There's a typical tolerance level, but the latency should not exceed typically 100 milliseconds. Okay, right? So you you see that you are tolerant to error but not to delay. Similarly, for live streaming video, you allow one packet to be in error out of 1,000, but in terms of delay, you are pretty strict, 150 milliseconds. But when it comes to email or some FTP download, okay, so the other type of the NRT type of applications, then you see that your error percentage has to be very low. One packet out of a million may be allowed. Okay, the tolerance level is so small, but you are not tight in the case of delay. It can be as high as 300 milliseconds.
Are these the maximum delay or
Yeah,
packet
it is the typical, maximum.
tolerable?
Yeah, tolerance level. Yeah, typical. Okay. So these are this is how the applications are categorized in LT. For LT, different applications are handled differently. Okay, so the applications are categorized and then they are handled. Okay.
So the PDB, sir, these are smaller when the server is closer to you, right, sir?
Yes, yes, it is.
Oh,
Yes, yes, it is. Okay. So for yeah, for real-time gaming, you have, I mean, the requirement is most.
yes, sir. We
Yeah.
know this, sir. We know this, sir.
Oh,
It is
you know.
typical for Bangladesh, sir. But
Oh,
if you're in Singapore, sir, it is 8 or 9,
you,
sir. So, yeah.
you're a gamer.
Yes, sir. We are all gamers now.
Oh, that is why you are so worried with the uh, with the I mean large content of the slides and all that. Okay.
You can
So
say that, sir.
so all these slides will be manageable if you can stop this
Gameless.
gaming. Yeah.
Yes, sir.
Now see uh, symbol error probability versus EB by N naught. EB by N naught is the EB means bit energy, what energy you have per bit, and N naught is the amount of noise. Okay, so it's actually similar to CINR. Okay, EB by N naught is similar to CINR. The energy, the desired uh, power level you have compared to the noise power level, the undesired power. Okay, but it is just considered uh, at the very low level. Okay, at the level of bit. And in the vertical axis, you have the error probability, how much error you may have. Okay, so you see that, say, if we follow the blue line, okay, as you are increasing your CINR, your error probability should drop, right? So these are called, I mean, because of the profiles like that, these are called waterfall curves. Because we have a, I mean, you have a waterfall curve, it is gradually dropping as you're increasing the CINR condition or EB by N naught. Now, the same type of profiles we are, profiles are shown here for different modulation levels. We discuss the impact of the modulation and coding. Okay, we discuss that when you have higher number of dots in the constellation, then it is more likely that in poor CINR condition, some the receiver will be confused with some dots. It will be mistaken in locating. Okay, the actual location, the intended location could be different from the at the transmitting end. It is different, but it is taking I mean a hazy area, a different area. Um, so you are confused. I think I have added another figure to the slide when I discussed. Okay, if you again download the slides where I discussed the modulation uh, MCS, okay, then you would find another slide showing how the dots can change their location. They can take hazy areas at the receiving end. Okay, how it looks. I mean, what is it? How they're different between the transmitting and receiving ends. Okay. So if you check the slide, your idea will be better. Now, when you go to a higher modulation level, so definitely you have more likelihood of errors for the same CINR or EV by N naught level. Now the AM here represents the modulation level 2, 4, 8, 16, 32. Okay. So for any EV by N naught, say when EV by N naught is at 8, you see that as you have higher and higher values of M, you have higher chances of error probabilities. For all of the modulation levels, as you are increasing CINR, definitely you have some improvement in the error probability. Okay, less packets will be in error. But among the different modulation levels, you have difference in performance. Okay. So this is how you need to choose the right modulation level for your current EB by N naught level. Okay. When if you can operate at higher M, then you are sending more bits in every symbol. So you have that benefit. But you also need at the same time need to consider okay how much errors may occur. Okay. So these things are will be managed in the link budget. Uh, the another thing we need to understand is the receiver sensitivity. Um, it is basically, I mean, if you look at the usual terms for receiver sensitivity, then usually usual definitions are complex, but basically it means what the lowest level of uh, power, okay, which is acceptable at the receiving end. The lowest acceptable level of power at the receiving end. You have some power uh, in the air, in the in the wireless link. You have some power level in the air. The receiver will capture it. So it how low this power can be. Okay, what is the minimum acceptable level of this power? It also depends on the quality of the receiver. Like some good quality receiver, a very low level of power can also be enough. Okay, it can work with very low level of power. So it also depends on the quality of the receiver. So in that case, the receiver sensitivity is better, and it has a even lower level of power. The sensitivity will indicate a lower level of power. But what I mean by acceptance, okay, how I can say that it is acceptable? Well, this power level that what I say that the receiver can work with, it is acceptable, should have the CINR to offer some specified level of bit error rate. Okay. The power level will be related to a CINR level, which is good enough for a particular level of BIR. So if the BER falls below certain level, then it's no longer working. You'll get disconnected, or there will be disruption in service. Okay, so this sensitivity means. Now, for link budget, we will set our requirements. Okay, I mean, link budget will help in one stage of this whole uh, settings. First, you target the maximum BER level, okay, for your application. Sorry, should be the minimum. I was mistaken in writing. I need to correct. It should be the minimum BER target, minimum BER. Okay. So it depends on the type of the application. As we say, as we saw that for RT type of applications, we had some BER. Okay, for NRT we had different. So one out of 100 or one out of 1000 or one out of million. Okay, in although it was in a number of packets. Okay, but anyway, so for BER or blur, I mean, you set particular minimum requirement. From there, you can set certain minimum EB by N naught or CINR. Okay, so in the first case, your setting will depend on the
Sir, I
application.
think your
Yeah,
voice is not clear, sir.
it's not clear. The internet connection may not be working well. Okay, how much? We have like 5 minutes left. Well, do you have any questions for today? I mean, we probably cannot finish that slide today. Uh, do you have any questions?
No question, sir. So the problem was from my end, though. Sorry.
Okay. Okay. Um, well, I have, well, you know what? I found it pretty difficult to take the attendance in every class, and also I was forgetting. So what happened? I did not track your attendance, but your attendance, what I uh, noticed that your attendance was pretty good. I mean, the number of participants was pretty good. Okay, and I was more focused on what I was covering, and you know what, uh, like in the elementary level of education, the attendance is almost everything. But what I feel at this level of education, it depends on the student, how he can learn. Okay, let him decide. Okay, so I'm not, I was never in my whole teaching career, I was never serious about the attendance. Okay, in my the physical presence of the students was not most important to me. Okay, and also in my, when we used to take classes face to face, in the beginning I told the students that in the classes you can do anything. You can do homework for other courses in the classes. You can sleep. You can bring your pillows and you can sleep in the class. I don't mind. Okay. You can eat. Uh, the only thing you cannot do is you cannot cause any disturbance to the class, because some people will be listening. So don't do anything that can hamper our communication as we are communicating. Okay. Otherwise, you can do anything. So I leave it up to the students at this level of education. You all are mature. Um, but what happened? Uh, I actually, there should be an official record of attendance, especially from this semester. Okay, that's now a requirement, because we are going through some accreditation process, and I'm also a part of um, different activities. So uh, now uh, I don't know how I should show the attendance for this semester. Do you have any suggestion for me?
So average, sir. So I think you took like 2 attendances or 3 attendances, sir. So
Right,
what you can
right.
do is, like you could give a form for 2 days as well. Yeah, you could give the attendance sheet for 2 days as well. We could respond there, and then you can make an average and then give it.
Okay. I'm going to put a question then in the classroom. Okay.
Okay.
So please write there. Okay, so it will be, I mean, we are almost 45.
Yes, sir. Sir. One small
Mm,
question, sir.
mhm,
Not question, sir. Just one
mm.
suggestion, or I don't know what you'll say this, but sir, I think Inan Marshall mentioned it yesterday as well, sir, regarding the lab final, sir. Uh, uh, will you be, sir, taking it after our semester final is over, sir? Because I think
Yeah,
there's a hardware part to it as well.
yeah, I spoke with Inan. What he
Yes, sir.
told him that I need to talk to the other teachers in this course. Okay,
Okay.
let
Okay,
me
sir.
let me discuss, and then I'll
Yes.
get back to you.
Okay.
Okay.
And sir, another thing, sir, regarding the quizzes, sir. We
Mhm.
have already given 2 quiz, sir, and the other one is coming up tomorrow.
Tomorrow. Yeah.
Yes, sir. So, sir, if you want to take 4 quizzes, sir, you take 4 quizzes. But if possible, give one assignment, sir, so that we
Well,
can get some marks,
yeah.
sir.
So I also
Yes,
discussed
sir.
it with Inan. There will be four
Yes,
in
sir.
total. Okay. So if we take an assignment, then it will replace one quiz.
Yes, sir. So you will be
Okay.
taking total of like 5 quizzes, sir.
No,
Let's say
no,
one will be an
no.
assignment.
In total
Wait,
four. In
wait.
total four.
Okay.
Well, I uh, see.
Yes, sir.
When you will be studying abroad,
Yes, sir.
what you'll see that they don't have the options of leaving something out
Okay.
like we
Okay.
have in our subcontinent. Like
Okay, sir.
in our questions, what do you do? We I actually protested several times in
Yes,
our
sir.
university that we should change this way, this method
Okay.
of examinations. That what you do, you have 8 questions and you need to answer 6 out of them.
Yes, sir.
That does not test you how you prepared for the whole thing. It is
Correct.
not, it is not elementary level of, I mean, I mean, you need to learn the whole thing, whatever we are
Yes, sir.
covering. All these things are
Yes, sir.
necessary. So how are you tested on everything? People are
Yeah.
leaving different things out. Okay. So we cannot risk this way. So this thing, there actually there, I mean, there are some other adverse impact too. So as you go abroad, you'll see that this kind of style of questions are not there. You have to answer all
Yes.
questions, and
Yes.
also all the tests will be counted. You attend a test, okay,
Yes.
and it is not counted. You won't see that. That will never
Absolutely.
happen.
Yes, sir.
If you appear for 4 tests, all these 4 tests will be counted. Okay, so these are the trends in our country. I don't say, I mean to say that we change all of our trends overnight, but
Yes.
what I mean that these are not the standard trends. Okay,
Yes.
these are not the right standards uh, to test the students. Okay, to judge the students. Okay, so
I agree, sir.
all we need that is a fair judgment. If there is lack of fairness, then the good students are deprived.
I
Okay,
understand, sir. I
right.
understand. Yes, sir.
So anyway,
Yes.
let us go for this is why I usually try to avoid assignment, because it gets very difficult for me to have the right judgment when there's an assignment. Okay. Anyway, so if it is, since there has been a request and I already agreed, the fourth quiz may be replaced by an assignment. Okay.
Yes.
So let's go for the class test tomorrow,
Yes, sir.
and I'll see you there. Okay.
Inshallah. Inshallah, sir.
Thank you very much for your time.
Sir, have you
Okay.
given the time of quiz tomorrow?
Well, it is 2 o'clock probably. Okay. The time was, I think, declared. Okay. And please go to the classroom now. I'm putting a question here to write down your student ID. Okay. Because I'll count the attendance for today. Okay. Did you hear me? I mean, please
Yes,
go
sir.
to
Yes,
the,
sir. We heard you, sir. It's
yeah,
okay, sir.
please go to the classroom.
Okay. And
I'm
sir,
gonna put a
regarding
question.
the assignments, sir, like, sir, we will try to be as fair as possible, sir. Like, not even lying, sir.
Okay.
Just go a little easy on us, sir. The syllabus is so big, sir. Like, you have so
You-
many things to give questions in assignment from. Just give an assignment, sir, please, sir. Just give one.
Okay. 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 Yeah.
Okay. Thank you, sir.
Thank you
Thank you,
very
sir.
much.
Assalamu alaikum, sir.
Walaikum assalam.